Ladies and gentlemen, it's been a great pleasure to attend another ANPA meeting. I was lured into coming to ANPA almost 30 years ago by Peter Marcer, who's unfortunately not here today. I also, about that time, met Eric Gerelle, been my research partner for many, many years. And the talk I'm going to give today was developed with him, but unfortunately, I'm sorry about this, John.
Go for it.
My friend died last Sunday. So the structure here and the thoughts here are shared, but you'll have to get them from me. Eric, I'm going to refer to him in the present if you don't mind. Eric went to Geneva to study quantum stuff, and his professor, named Professor Yauk, he unfortunately died, and Eric had to move into industry, which is where I met him. I was posted to Geneva, and we became friends, and we worked together, and he had a little joint project at CERN, and the project was to get a computer company, our employer, and the CERN physics community to understand each other's requirements. And Eric did a fantastic job, and I, as his host manager, went with him on the third Thursday of the month to the fluid dynamics sessions, which were held in the beautiful little villages around CERN. Fluid dynamics, of course, was a misleading title for the administrative management, and Eric and I decided that we'd do some data collection, which was how many restaurants sold reasonable quality San Josef wine.
Yeah.
We were then fired, the company self-destructed, and that's how our joint venture started. When I was with him just before he died, we talked about the importance of our joint venture and ANPA, and it was way up on the things he'd done in his life. And this joint venture was where he reckoned he grew up. He said forcing people to manage other people is a big learning experience. And when we got going with our research program, we decided that we should reflect on what it was we were trying to do. And we both had very bad experiences in research. I'd done research myself, and I'd managed research people and so on. And we concluded, he had the same sort of experience as I did, that you could not pay people to do research. You could only find people who were passionate about something. So our work together had absolutely no external constraints, no money constraints, no time constraints, no limitation on the goal, no political bullshit, anything like that. Just the two of us for quite a long time. In Geneva, there are two major cultures of relevance. One is CERN itself, which is obviously relevant to the work going on here. In fact, a great talk this morning by another Michael A. Joe. And in the other side of things, there's, it's now called International Geneva, which is around the UN and stuff like that. And this is a completely and utterly different culture. So we decided that when people asked us what we were doing, notably wives, we couldn't say we're going out boozing for red wine. We said we're going modelling. But it wasn't satisfactory enough to the CERN people, and they said, what are you doing? And we said, we're working on physical systems theory, meaning maths and stuff like that, right? All of you know about that, and had maybe an overdose in today. But the other people, the UN people, they wanted us to do stuff for them. And there was a man, quite a good man in our social circle, who came back from some ridiculous conference in the US, 6,000 people or something, not a healthy conference of this sort of size. And he said, there was no progress on the underlying theories of international relations, but somebody is now applying quantum theory to social relations and international relations. Could you do it? And we said, only if you take us seriously. So what we did was we tried, this is sort of like C.P. Snow and all that stuff, right? The humanities and science people, it's not that they just don't understand each other, they actually detest each other. There's no overlap in language and stuff like that. Even if you have different German translations, it still doesn't work. Right? So, what we actually tried to do was think really, really hard about what thoughts had influenced us, Eric and myself, and bring these together at the beginning of a very bumpy period. So we started, in effect, in 1993. I dragged Eric into coming to ANPA, and he liked it, but at the beginning his personal finances and stuff didn't allow him to do anything. But I've read and reread combinatorial physics and stuff like that, and what has come for me is the enjoyment of meetings like this, meeting people with open minds, working on entirely different things. So I imported that into our joint venture, and then I tried to sell without any success the idea that information should be regarded as, if you like, a notion at the same base of thinking as energy and matter. And I got this by working with Tom Stoner, and after a while I gave up trying to influence Eric, because I knew that maybe 2, 3, 4, 5 years ago it would come back to the surface. Unfortunately, Stoner moved to the States. I went to see him a few times. It was quite an interesting thing. He and his wife were weavers, and they built a house. Actually, they built a weaving machine, and then they built a house around it. So with great pleasure, I went over there, and he was writing books, and one of the ones which I've got the title in my mind is Information and the Structure of the Universe. And what happened later, about 5 years ago, was there were articles in reasonably, shall we say, reliable publications about information in fact being given, shall we say, elevated status. Lastly, I was given by a man who was frightened by it a book called Life Itself by a man called Robert Rosen. And Rosen had done a lot of good things, and towards the end of his life he tried to pull all of his contributions together in one book, that book, and he admitted this was the hardest thing to do. Now Eric and I, when we knew that he was probably going to fail, within a couple of years we started on our work. So this presentation in a way is just a way point, and where we were trying to write the equivalent of Stoner's book. In other words, put what we'd done together in the last 30 years or so. Just 2 or 3 points on Rosen's stuff. First of all, he said that his life purpose was to understand what is life. And he asked the question, whose job is it? And he said the physicists are not doing it. And then he said, what about the biologists? Surely it should be them. He said, well, I only work on dead people. The life bit is gone. So he said, I'm up for it. He was quite a talented mathematician, and he then studied not on the surface, but the really deep stuff from Newton. And he concluded that Newtonian thinking, particularly in the West, has influenced our minds so much that we cannot think through what an organism is, because Newtonian thinking is in effect saying everything's a mechanism. Done. So he then started to chip away around the edges, and I'm told by reliable people who may have met somebody who knows about category theory, I don't know if they're only in the room, and he contributed to the basics of category theory years and years ago. Is this true? If it's not true for me, I'll ask Mike Head.
There's a lot of category theory in his stuff.
Okay, so getting to, as it were, the scope of what Eric and I started to put together for this presentation. It's, as somebody said earlier on, I've rounded 13.8 to 14 billion, I hope you don't mind with that. And it looks like there are phases. And what we have tried to do, Eric and I have tried to do, is start on the other end, the right-hand end of this. We are not trying to help interfere or in any way get involved with the heavy stuff from cosmology, geology and stuff like that. We are more interested in when you move out towards the other end of the scale. The numbers that came up this morning, unfortunately Michael, the other HO, he used linear things, we use log things, and it certainly needs to be done that way because the human part, as far as I'm aware, is only about 250,000 years. So I leave you to figure out. John, you're good with 10 to the minuses. It's not a thing. Okay. Now, just a few thoughts about this one. As I said, in Geneva, you get influenced by the various aspects of the UN system, the UN agencies, the NGOs there, and all that stuff. But there is a pride that they actually started the sustainability movement. I actually knew the guy who claimed that he invented the phrase sustainable development. But when Eric and I looked at an earlier variant of this thing, these are called the SDGs, there was a prior stage called the MDGs, we realized that the big problem was that their clients, alleged clients, the investors in sorting out sustainability, are wanting a holistic picture. And you can see from the diagram, it's not a holistic picture. Now we, computer modeling people, have been coerced to look into how we could possibly help develop a holistic picture. And that is because each of these things is nowadays a massive data collection exercise, and people got theories and stuff like that, and they're putting all this stuff together, but there's no overarching framework at all. So, working with our man who complained about the absence of progress on international relations, we finally got him to agree we would not use equations, he would not use only long words, and we'd settle on the diagram. As somebody else earlier on referred to Aristotle, behind this diagram are the four causes, and the environment is the world, right? So our choice of words was the inside, and their choice of words was the outside. Call it them being the humanities people. So in here, endowment, if you like, the material cause, it comes in the economy. Society is supposed to do good things with that, and out comes well-being. The other constraints, entitlement and capacity, we needn't bother at the moment. But in order to model, if you like, a successful system, we started off with this little atom. If you wanted to model something complicated, a bit like Lou does, you just put them together and the braids go on, as it were. Now, that wasn't really very helpful. Even that level of, shall we say, precision or formalism was obnoxious to people doing weird stuff, like worrying about poverty or international relations. Now, one of my hobbies is cycling. And it just so happened I proposed when the Tour de France was on one year that we used a peloton as a model to indicate all of the complexity of trying to get groups of people together. I must tell you, to Eric's shame, when I started droning on about the peloton, the yellow jersey and all that stuff, he actually fell asleep. Now, we had quite a lot of benefit by looking back on some work by a man called Theodore Modis, who actually originally got some ideas from the IASA people in Luxembourg in Austria around the idea of cycles. And in particular, there is a relatively well-known cycle called the Kondratiev cycle. And this top graph here is more or less a sort of extract from some work in probably the 1970s. But what we were doing, I'll show you a little bit later, we were using S-curves to do this. Now what we discovered was that there was a firm belief that something external like energy drove the Kondratiev cycle. And it was about 54 years and that was it. We proved three things. It wasn't dependent on anything in particular. It was a sort of intrinsic thing with the way that nature works. Secondly, it wasn't 54 years. And thirdly, it wasn't a cycle. Otherwise, it was perfectly right. So here is the guts of a modelling thing, which I do not propose to go in because I think everybody's had too many funny figures and diagrams like that today. But you can see on the left the idea of an S-curve. There's a, if you like, a midpoint, and we note that. And then we're interested in the maximum value and so on and so on. Now what we have discovered, and this is a very important point, is that when we go out into the world to collect data sets, there's two things that happen. First of all, the mere fact that these data sets exist means that human beings have been interested in that stuff. I won't going to show you more than 2 or 3 of these, but we've had over 60 data sets, and they all follow this sort of sequence of S-curves one after the other. And they fall into little buckets. There's a sort of discreteness there. We're not absolutely sure whether we introduce the discreteness ourselves or whether in fact nature is like that. This is one of the things we discussed and argued about week after week, right? So deep down in the modelling system it's like that, and this is where we, if you like, commit, partly because of Rosen, to the idea of a complex adaptive system. So, if you like, adaptiveness comes at the individual level, at the group level, and the diagram's only got room for just 2 or 3. But in fact, it's a much more, if you like, a stacked series of things. If we take the world that is out there and all this data which is available, we actually very rudely called it our experiments, right? People were supplying the stuff. What happened was in the 1995 period, we would spend a lot of time collecting data with the red wine, of course. And then later on, we realized with the people who'd invented internet and big data and stuff like that, that they were doing it for us. So we would sit there and Eric would get his model out, click a few things. Where's Grenville? He's here somewhere? No, he's gone, right? And using Grenville level, you know, Excel spreadsheet stuff, we get some answers just within a few minutes. It's absolutely amazing. And we realized the whole idea of relationship between theory making and experiments was just completely changed with the access of all this information. Eric and I dug this stuff out about 2 weeks ago in about 10 minutes after we'd had this, if you like, idea that we should look at self-organizing criticality and stuff like that. So from the point of view what I'm interested in, or the model's interested in, the slopes all, as it were, have tails. So whether you look at sand grains and things like that, you know, there's the Zipf's law in language studies or linguistics, stuff like that. There are many, many examples of systems which are self-organizing around the criticality notion. Now in physics, you probably know, there's lots of power laws. And in fact, where's Nikki? We are very interested in the combinatorial hierarchy because we think it falls into this business here, right? By the way...
You should be coming on to Papa. Talk John, you'll be thrilled.
Okay, just as an aside, I promised to lighten things up a bit. When I was with the regular Cambridge ANPA groups, we called ourselves ANPA, full stop. but occasionally there were some strange people from California, and they called themselves ANPA West. Now, the combinatorial hierarchy is usually abbreviated to CH, right? Eric and I, we called ourselves ANPA CH, demonstrating our interest. Right. I mentioned briefly the Millennium Development Goals. What happened was our man who complained about quantum theory not being inserted into international relations, he unfortunately invited us to give a talk on our model. And Eric stupidly said yes. I think he was in need of money at the time or something like that. And there were two things which I remember. This was I don't know, maybe 2005 or something like that. I don't know if anybody has got long enough memory or their brains are working a bit better than mine, but there was a problem to do with the ozone layer. And two things happened. One was the powers that be decided to do something about it, and probably more significantly, a cheaper, non-poisoning the ozone layer chemical substance was discovered almost immediately. And when we were looking at this, all the data before and after was there. And we modeled it using the system, and this is what we discovered, that if the thing was like a switch going over, obviously one can imagine if this happened with CO2, then in this case it took approximately 140 years for the entire atmospheric system to cleanse itself of all the CFCs. I thought that was a really, really scary finding. We were proud that the model worked, but it made me get even more excited or more enthusiastic about joining in the sustainability movement. The other one which came out in this period was one of the MDGs was to do with child mortality. As I said, the development things to some extent are just data gathering things and so on. They are not, at least they were not at that time, particularly effective. But here you can see lots of countries, and with the usual, if you like, tolerance of people doing modelling, we found that the child mortality rates were all, in some sense, on some mysterious pattern which is common. And then when we put it all together, this was when it got really exciting, because when we started the modelling, we took this data, which other people had been very kind to produce for us, we fed it into an equation which gradually got more and more complicated, and then Eric did a fantastic job and simplified it, and what happened was that weird numbers which you sort of people were very familiar with, like the Fibonacci number, or if you like the golden ratio, popped out. We realized that we were working on the edge of chaos theory, and we looked at what Feigenbaum was doing and found his constants, which are known as alpha and delta. And here is a sort of idealized version of what we discovered about that time. So now we were really enthusiastic. This model is not just keeping us away from the pubs and the wine, it is actually producing something interesting. So here's a very specific, I think very helpful example, which was based on that model which we forced the, if you like, the humanities representative to agree to. If you look on the top with the brown line and the green dots, that is the human survivorship over time. As you can see, you know, people up there, I'm sorry to hear this because I'm on that last curve there in the 80s region, and that's what it is, right? Now, if we look at Niger, way back, and then if we say, where was England in 1650, then you can see that too. Now, what's happened, of course, is technology, things like vaccines and knowing about various diseases and stuff like that, is that if you bring in that knowledge, then you can quickly change things. So what happened then in the context of the various countries looking at these problems like child poverty and stuff like that, like child deaths and poverty and so on, is that we discovered that we could orchestrate the recommendations for the entire, if you like, global package. We say, look, it's pointless trying to improve the, if you like, situation in Switzerland. You know, you get 5 deaths per 100,000 births per year, and you want to have 10% increase. Why don't you go to Malawi? You know, and it turned out that we could use expressions like Malawi is 140 years behind Norway. You know, very interesting improvement on the metrics, which we suggested and somewhat adopted in the SDG phase. I had the privilege once of being on a course which took me out to San Diego, and I sat in the chair of a man called Maslow. So for that one simple reason, I followed Maslow's work, and he is often given a sort of hierarchy of triple or 3 or 4 level thing. But what actually happened was the following. I mentioned to Eric, I'd sat in Maslow's chair and I thought about Maslow's triangle was really important, and he said he'd done some work in Africa working on how you could find out, for insurance purposes, how much people earn. I said, no, they won't tell you that, but they will tell you how much they spend on food. So this sort of proxy idea came out, and in the middle of that work that he did years and years before, there was a thing called Engel's law. So using that stringing theory of the various bits when I mentioned Aristotle and so on, we did a 5-level linked model, and we rediscovered Engel's law in the way that, if you like, the numerology came out from this investigation. So there we, if you like, found some victories. Very recently we were thinking hard about what we might learn on what you might call the left-hand side of the $14 billion picture, 14 billion year picture, and what is there in the social world which might give us a deeper understanding of what's going on. And we discovered some work where there's like 2 petri dishes being separated and then put together, so the niche, the food supply, is the same. And it's always the case that one always wins. So we concluded that if there's competition between 2 populations and one always wins, it's roughly equivalent to Paoli's principle. Buried there in, if you like, the biological world. I hoped that we were going to find more of these, but not so. Oh, wait a minute, I'll just go back one more. We applied the model one time with some people who were puzzled about the following situation. In America, there was a serious reduction in using lead in fuel for cars and other reasons and so on. And then 17 years later, the number of deaths and the number of suicides changed. And some people put forward a theory that this was, if you like, relevant, but there was no, if you like, connection. Now, I haven't mentioned it because that would have been too busy, but we have tried over and over and over again to get a handle on causality. And we took the data for both the lead and the deaths, and we could show, using our modeling system, that they were in fact related. There was a 1-to-1 correlation. 17 years before, there were some young people, you know, if you like, very fertile young maidens, very fertile young people, and that stopped. And later on, when they were in adulthood, it all became, if you like, a much more successful present situation for them.
So the way to solve the global population crisis is to go back to put lead in the petrol, right?
I knew I could rely on them for an insight into serious work here. Okay, I don't know enough about the, shall we say, attitude nowadays to the Big Bang, I've got it in my head that it was originally put forward as an insult or a joke or something like that. But nevertheless, a lot of people put a lot of work into it, and here's, if you like, the current acknowledged thing. And using what I briefly described, there wasn't time to go anymore, this idea we have, which is to look at things with the S-curves and where they, if you like, turn, we call them milestones. And then using this, which is sort of like a proxy for time, we're not very happy with the, if you like, standard dxdt sort of idea. And then on the big history thing here, as we call it, you can see, and then again, we found that we were getting into some very deep connections with the theories of chaos. So Mitchell Feigenbaum, it's a lot of people dying this year. John, sorry about that. He inspired us to look very carefully at what is sometimes called doubling to chaos and so on. And the, if you like, alpha and delta constants which he uses kept reappearing early on in our models, and now I'll have to do it on my own, but I was trying to understand more deeply why it is that we're into that sort of business. Back to the combinatorial hierarchy, very briefly. I remember quite a lot of people putting an effort into understanding the relationship between the funny numbers, you know, the 3, the 7, 137, all that stuff. And it stuck in my mind, and I was nagging Eric to look into this. And we decided that probably if that was relevant, and I've drawn that diagram in a different way here, if that was relevant to the physical period and we're scoping here, we took out of here, I think you mentioned, Peter, the renormalisation group. Now the normal renormalisation group, there's a term which is regarded as trivial. But we put it back in and we've fetched it out, and we think that it's actually applicable all the way in. In other words, it's like the contractive cycle thing. It's not related necessarily to something that is in there unless there's a meaning of energy all the way along, which is a possibility. So we're working on that. This is, if you like, a boring table. You've seen lots of tables like that today, but it's our way of expressing all of the stuff which we've worked on, and here put together in one mammoth sort of graph. Each of these lines shows data sets which you've used. So what we discovered is that there's a certain sort of discreteness. The Kondratiev cycle in this scheme would be number 17. Another cycle, which is 2.5 divided into that, and that is number 18, and so on and so on. We are still a bit puzzled as to why numbers appear, ideas appear both sides of this parabola, but it does seem that this lower part is like the gene of the upper part. So this is, if you like, work in progress to connect it to the physical world. What Eric asked me to do was to try and end the talk with something which would get people talking. He said they must surely be interested in the Theanthropic Principle, why it is that the values of the gravitational constant and all that stuff are what they are. I said, people know about that. Don't let's talk about that. But he said, well, what about this? And this is a very interesting notion. If we buy this idea that sentience arrives from living systems, which arrives from information systems, arrives from physical systems, what can we imagine going on out here? And there is some literature, if you want to look it up, called the Theanthropic Principle in Intelligence. It seems to be that humans have got, if you like, to a special state via 3 things here, 3 divisions. And the last couple of months, when I was poking my nose into Goethe and stuff like that, there is a theory buried in there that when humans started to stand up on their hind legs, they actually then became aware of their own identity, which seems to me to be an interesting notion to plug into a system like this. So it's late in the day and I've gone through very, very quickly, but I would like to just leave a recommendation for a book in which this idea is pursued. Hi.
Could you elaborate on what you mean more specifically when you say their own identity?
So what was the question?
Sorry.
Was the question?
It was on the very last point I made. Identity. A mature human being usually is able, if they're healthy, to articulate who they are and who they, if you like, might want to be and stuff like that. This seems to be regarded by people who are studying, normal people and people with PTSD and stuff like that, that this is an important thing to get right. And it seems that this didn't happen 300,000 years ago. It came, midway, perhaps, when people stopped hunter-gathering or something like that. But that's what the idea is, that people can articulate who they are as a concept, not their physical body only. You're the boss.
Well, go on.
Very quickly, looking at your last graph about intelligence, I had to think about the latest book by James Lovelock, Novacine, who says that the last 250 years it's like Anthropocene, so era of the human intelligence which started with Industrial Revolution, but
Yeah.
now we are sort of going into Novacine, which will be an electronic intelligence, whichever. Electronic? No, yeah?
Well,
No.
what does he say? Artificial intelligence.
Artificial
He used
intelligence,
that.
yeah.
Yeah. When Eric and I were using this graph, which we did quite a lot, we put a sort of square around this part here, where there's humanity.
Mm.
And another one, another thought, which comes up here, is this idea of going towards some sort of terminal situation. I'm trying to think of the exact writer who talked about this. You know what I'm talking about?
Jeffrey West.
No, West is interested in the idea of scale.
Yeah, I mean he's talking about a terminal situation.
Yeah.
Right.
I think there's a Terry Deacon's stuff is interesting.
Sorry?
Deacon's stuff is interesting.
Yeah.
But there's another biologist who's based at UCLA who is actually following Peter's work called John Torday, and he's got a story which I think probably fits the story that you're trying to tell more clearly.
Right. The reason that I was particularly fascinated with that is the following. First of all, it was a 10-year project with 10 people coming and going, postdocs and so on. And it was a really serious effort. And he had 2 or 3, I thought, really good ideas. And if the idea, if you like, of some form of energy is coming along here, what he said was that you have to somehow get the idea down to be work. So obviously the relationship with energy and work and so on. So that indicates that up here, the idea of thoughts, prayer, and that sort of stuff, work, takes action in the physical world as well. So that was partly because of the intensity of the work over 10 years. I thought it was quality stuff. Here's an aside here. I developed a habit some years ago of making a PowerPoint slideshow of books which I really didn't understand. I've never finished the slideshow for life itself, I got into capitalism, and the slideshow was longer than the book. And the one for this one is up to 134 slides, and I haven't clearly finished that either. But I've got about 6 or 7 books on PowerPoint slides if anybody's interested. Other questions?
I missed, and it's not very legible, what these...
I was intended to
these
be
4
awkward to you.
stages, so I somehow missed that, the 4 stages. So you've got like physical, something sentience, something intelligence.
Physical, information, living systems, sentient systems.
Oh, physical, information.
It's a bit like the Maslow thing. Probably other people had 5 or 6 segments. But what is tough is to find this transition between any one of the stages.
Yeah.
It may not be linear because some people may be on higher level for no reasons whatsoever. It's known as the traditional Maslow diagram. If you look at what was happening in concentration camps, rather than some people, rather than fighting for survival, would sacrifice themselves for the sake of others, which in this traditional pyramid wouldn't work.
Well, I didn't hold anybody back from dinner, but I just 1 or 2 closing comments, and that is that, as I said, Eric and I were working on putting all of our stuff together, and this was a snapshot put together, as you can imagine, in a bit of a hurry. But the idea I have, because I enjoy coming to ANPA so much, to hear people's own evolutions and so on, is to come back with the work in progress after 1 year.
Yeah, great. Well, one thing, because you mentioned, when you were talking about looking at groups and things, you talked about the cycling peloton, and before that you'd had this thing about competitive something and collaborative. And I went to a really interesting talk with a wild group, it's called Radical Anthropology Group in London, in UCL, which claims to be one of the longest running groups ever. So anyway, but it was a couple of people in Africa who've been going out and living in this particular community, and they sort everything out through music. So, like they live in a communal way. They don't have, they don't have big problems. They don't have people dropping out. They don't have, they whenever there's a problem, they kind of all get together. It's incredible. And they've got these kind of different songs for different things, but they can also improvise. And they like run around the village. They're kind of dancing and singing. I mean, it's amazing stuff. And in fact, the woman who was presenting it got us to do so. It was great.
Can we do it at ANPA?
Oh well, we should do it. Yeah.
We did do some stuff like that. Well, not like that. Andrew keeps reminding me that Hermann Hesse was right when he wrote The Glass Beetle. The two eventually, society had evolved to the point that the two only disciplines which mattered were maths and music.
And they were the same discipline.
Yes. Well.
Yeah. But,
Nikki, did you want me to put that diagram up and talk about it and send everybody to sleep? Is that
No.
the idea?
I was just thinking that you could look into this other thing, like that it maybe doesn't have to be competitive. I mean, it's just like whatever Lynn Margulies and stuff. Talking about symbiosis, blah blah blah.
But, I mean, if you know anything about this, it's not all competitive. Teams team up with other teams, and there's politics, and there's, if you let the environment go on, there's the year-by-year hiring of young people. Currently they're buying people from Colombia because they live at 3,000 meters and stuff like that.
Yeah.
It's very complicated.
I know, but they do take drugs to win.
I was wondering.
I'll tell you that one.
I was wondering, each of the cyclists have a tag, right?
Yeah.
And that the data of where the location of each cyclist is somehow recorded somewhere, right? Is there a dynamic sort of viewing of how the who replaces whom and like what groups form in a sort of time axis? Is there any information like that available?
I believe the richer teams do have that, because every bike has got an RFID on it, and it's identified with the cyclist. They also record their heartbeats and their general health and different other metrics. But, you know, the usual stuff. They've got a power meter on, so they can figure out how much energy they've been using, and they position people with nutrition. You know, let's say it's a 200 kilometre stage, there's 4 or 5 mountains. They know that if they don't get fed, they're going to get very weak at this point. So it's not quite real time. On the other hand, cycle racing, they now have machines which can measure, as they go around the track, their, if you like, aerodynamic factor. So that if they're trying to do what they call the 1 hour record, right, they can actually measure them as they go around, and, you know, if people open the doors or the temperature changes, stuff like that. So it's close, but not for the peloton as a whole.
Any other questions? Thank you.
Thank you very much.